4. So you still have time, guys. Oh, you have a lot of time, I have to say. So today is February 12. 12 too much 4, you have a lot of time. Because this assignment number 4, to some students will be hard. That's it, just to some students. Okay, not all of you. Okay. Hopefully we're gonna have time to cover the concept. Most of the concept today, or maybe half the concept, so that you can start with number 1 and number 2. Okay. So I believe that as we finish the class, so then you can do number 1 and number 2. Okay. We're gonna finish all the graph of the function. So last time we left at tangent function. We never touched the graph, but we will be touching the graph today. I want you to go back and fix one of the example. Actually, that example is good. The graph is good. We just need to change a little bit. So right over here, let me see. So on the graph, the example of the secant, okay, y equal to 2 cosecant pi over 2x minus pi. And I remember that I flipped number 2, which is not good. Okay, I did like this. I do just 1 over 2 cosecant pi over 2 minus x. So we cannot fix the magnitude, okay, the amplitude. The amplitude is still there. So the amplitude is still on the top. Okay. The amplitude is still on the top. Okay. However, when we graph, of course, the graph of the cosecant is based on the graph of the sine. Okay, and when you graph the sine. Graph y equal to 2 sine pi over 2 x minus pi. You see, that's why when we graph the sine, the amplitude of the sine is 2. Okay, it's not 1. Okay, so the amplitude of cosecant is the same as the amplitude of the sine, and vice versa. Okay, the graph is still good, so you just need to change. You keep number 2 on the top. You cannot change number 2. The 2 is still on the numerator. So you ignore. I believe that you ignore the. I give you 2 emails, so you ignore the first email. Last time I told you to fix this is 1 over 2 here, which is not good. Okay. So you're gonna just go ahead and write this part, okay, so that you know that you have to graph y equal to 2 sine pi over 2 x minus pi. The amplitude you have to carry it on, okay, with 2, not 1 anymore. All right, got it? Okay. Other than that, everything's good. Okay, the graph's still the same, everything the same. The amplitude is still 2, and we flip it over, so we still start at 2. Okay, good. All right, so I believe last time we left at tangent. The graph of the tangent. We talk about tangent. We talk about a period and tangent function. And we say that the period of the tangent function is pi over b instead of 2 pi over b. Okay. And we also know that the range is from negative infinity to positive infinity. And the domain is everything except for pi over 2 plus k pi. Everything except for this. Because tangent function is what? Tangent function is equal to sine over cosine. So we're not allowed to have 0 for the cosine part. Okay? And because we're not allowed to have 0 in the cosine part, the x must be different from pi over 2 plus k pi. Because at pi over 2 plus k pi, the cosine turn out to be 0. You look at the unit circle. Okay. So this is cosine right here. This is 1, 0, negative 1. So over here at pi over 2, and you keep adding another pi. So this is pi over 2 here. And you keep adding another pi, it go back to this position, and that's why the cosine turned out to be 0, which is not good because we don't want to be 0 on the denominator. And because the domain is like this, so we have the vertical asymptote. So this is where the vertical asymptote will be. Okay. And we have, of course, we have infinite many, the vertical asymptote. Okay. Okay, if you guys have not got the assignment number 4, go ahead, grab it here and turn it in. Okay? So, we can displace the period pi, extra pi over here, so b will be 1, so it will be pi over 1 just pi. Okay? We can displace the period instead from 0 to pi over 2, or from 0 to pi, we can display it between negative pi over 2 to pi over 2. Because negative pi over 2 is also the position when we have the vertical asymptote. So let's start with the graph of our tangent. So this is the graph of our tangent. So, because x is different from pi over 2 and negative pi over 2, okay, so it's good if you can put plus, well, you don't have to, because k represents k equal to 0, plus minus 1, plus minus 2, and so on. So we can displace one period of the graph between negative pi over 2 and pi over 2. So this is pi over 2, okay, and negative pi over 2 over here. Negative pi over 2. And we know that if tangent, if the angle is 0, if tangent of 0, we will have x equal to 0, y equal to 0. If x equal to 0, so tangent of 0 is sine of 0 over cosine of 0. Tangent of 0 will be sine of 0 degree or radian over cosine of 0. And sine of 0 give you what? Remember? 0. And how about cosine of 0? 1. So that's why tangent of 0 is 0, and it go through the origin here. Okay? And because negative pi over 2 and pi over 2 is the vertical asymptote, so we cannot cross that, so it's going to look something like this. There you go. Okay. So my graph over here, it just displays the period, one period, which is pi. You see, between negative pi over 2 and pi over 2, which is pi. Of course, we're going to have a lot more. Okay, we're going to have a lot more. So substitute who come late. So go ahead, fix one of the example last time. Just ignore the first email. Okay. Number 2 is still on the top. Okay. It's not really that. I wrote it down over here. That's why kind of confusing a little bit. Number 2 is still on the top. Okay. Other than that, the graph will be the same. Okay. But just plug it in and then check it's still the same. But when you grab it, you have to grab 2 sides. So you have to carry the amplitude 2 right here. So we're not going to grab side anymore. So that's why we still start at 2. The amplitude still change. Okay. So this is the graph of tangent, and this is the parent function. You have to memorize it. And we're going to use this parent function to do transformation for the more complicated tangent. For example, we want to graph this. We want to graph f of x equal to tangent of pi over 2 x plus pi over 4. Okay. Let's see how we're going to graph this. Well, we know with amplitude over here is 1. Okay, actually, it's not going to change much. You know, for tangent and cotangent, the amplitude is not really a big problem. Okay, for sine, cosine, secant, cosecant, yes, it is. And so the period now, we got 2 will be pi over b. What is b over here?
1 over 2.
Pi over 2. Pi over 2, not 1 over 2. It will be every value in front of the x. So the period is pi over 2, so it will be pi over 2. U2. Okay. So let's see if we can grab this. Okay. Let's see again. Let's start with our, and let's see if we have any interval. We have boundary or not. No. So we're gonna grab all of them. But of course we don't have enough space, so I just grab maybe 2 periods or maybe 3 periods. Okay. Alright, so I know that the period is right now is 2. So if the period is right now is 2, how about the phase shift? Oh, we need to do the phase shift also. So we're gonna let pi over 2x plus pi over 4 equal to 0. So this is phase shift, and we need to see that if it is moved to the left or moved to the right. So this is turned out to be what? Pi over 2x minus pi over 4, right? Okay. And x equal to what?
Minus 1 over 2.
I cancel this, so actually negative, negative half. So negative pi over 4 divided by pi over 2, you can change flip. So I have 2 over 4. I simplify. So I know that it's moving left or right? Left or right?
Left.
Left. Yeah, it is left. Okay. All right. So let's see. Let's start with our first period. Right now the period is 2. So over here will be 1, and over here will be negative 1. And we will have the amplitude. We will have the asymptote. Okay, so this is just a parent function, okay? The parent function with new period. Okay, we're not going to use this period anymore. Alright, so the tangent will look like this. So I'm going to use the dash line. Like that. Okay. So this one will be what? This one will be tangent of pi over 2x. Alright, now we're going to shift. When we move left, half. So over here now, this is 0 to 1, so half of them will be a half, right? Okay. So the origin, right now the origin is the origin is not at 0, 0 anymore. It's over here because we're going to move half unit to the left. Okay, so it will be here. So that will be our new origin. Okay, the asymptote will be here. I don't have red color, so just right now. Okay, and this one I move another half here. So the new asymptote will be like this. Okay, and we will have something like this. There you go. I don't know if you can see that. Can you? Good? Alright. So I just move half of the unit to the left. Okay. We're not going to move up or down because right now there's no vertical asymptote at the end. So that would be, the graph over here displays 1 period. Okay, so if they want you, for example, they want you to graph between -5 and 4, then of course you're going to have like more stuff over here. Okay, so you're going to have something like this, for example. maybe you can have something like this. Okay. Okay, so this will be what? This is 1 here, so it will be 2 here, for example. If they want you to graph between, -1 and 2, then you have to add another branches to the graph. Okay, good. Any question? Okay. So all you have to do is you have to find the period, our new period. Okay, you need to find the phase shift. Amplitude is not a big problem here for tangent. Okay. If it is add or subtracted by k unit, you move everything up. So if it is like, for example, you want to move up 1 unit, you move the whole thing here, the whole origin up here. Just move up. And the range will be the same. Okay. The domain is depends on the question, how much they want you to graph. But if I don't put anything, then you just need to graph like maybe 2 or 3. This could be enough. Okay. Okay. If I put something, for example, I want you to graph between -1 and 6, then of course you have to keep adding more period, more branches there. Okay. So that's just the graph for tangent. Now take a look at take a look at the cotangent. That's going to be the same or not. Okay. So that's this tangent function. Now we're going to cotangent. So the fx will be a cotangent, the general one, bx plus c plus k. And everything will be the same, calculate the same phase shift. The vertical shifting up or down, depends on if the k is turned out to be positive or negative. Okay. Okay, so let A and B equal 1, C and K equal to 0. Then we're going to have the parent function. And we're going to have fx equal to cotangent of x. And we can see that if this cotangent function, the domain will be the same as the tangent or not. Okay, so we're going to change cotangent. Cotangent is cosine over sine. Okay, so right now we have a fractional form, and we know that under the denominator we're not allowed to have 0. Okay, so the domain will be everything different from 0 at the bottom. Okay, so we need to find the value of x that make the denominator 0, which is not a part of the domain. Okay, let's see. We have a unit circle that looks like this, and this is sine, and this is 1 here, 0 here, -1 here. What value of x so that sine of x turned out to be 0? 0 is one of them. What else?
Pi.
Pi. What else?
2 pi.
2 pi. Of course, this is when you go counterclockwise. You can do clockwise also, right? So you can do like this. And we're gonna have more. I'm gonna have 3 pi and 4 pi and k pi. So our general will be k pi. Okay, with k equal to 0, plus minus 1, plus minus 2, and so on. What does it mean by that? It means that at k pi, x equal to k pi, the function is not defined. Okay, so the domain will be everything except for k pi. Okay, so we're gonna have, of course, we're gonna have vertical asymptote there. So this is where vertical asymptote. Okay. All right, let's see so we can grab the tangent, the cotangent. Okay. So the period right now, so we talk about period. So the period will be 2 pi over b in this, pi over b in this case, and b equal 1. So it will be pi over 1 equal pi. So the period of the Paris function of cotangent is pi. Okay. And we can displace one period between 0 and pi. Okay. Instead of between negative pi over 2 and pi over 2 in this case, we're going to start from 0 and pi. So we're going to have a vertical asymptote like this. At 0, of course, it's one of the vertical asymptote. At pi, this is vertical asymptote like this. Okay. Alright, anyone can tell me if x equal to 0, cotangent equal to what?
Cosine? No.
It doesn't work, right? It's undefined there. How about if x equal to pi over 2? Okay, let's say x equal to pi over 2, and cotangent equal to what? Cotangent of pi over 2 give you what?
0.
It will be 0, right? Because cotangent will be what? We're going to plug them in, so cosine of pi over 2 over sine of pi over 2. Cosine of pi over 2 is
0.
Is 0.
0.
It's easy to get. There will be a 0. And sine of pi over 2 is
1.
yeah. So that's why cotangent of pi over 2 is 0. So we're gonna have over here. It means that the graph of our cotangent is going through pi over 2. Okay? And it's gonna go like this instead of the other way. Cotangent. There you go. And of course, we can do more if you want to, but I just want to grab one period only, which is pi over here between 0 and pi. Okay? So that is the graph of our cotangent function. Okay? Let's take a look when we have to do a transformation. Okay, I want you to grab, how about this one? This is interesting right here. I want you to grab f of x equal to -2 minus cotangent x minus pi over 4. Ooh, wow, this is kind of interesting, right? So you look at the question and you can visualize actually the whole graph in your brain ahead of time. You know, we know that we have to grab the basic one, cotangent, with the new period. Okay, and we have to do the phase shift. In this case, look like we have to move it to the right. Okay, I'm going to calculate phase shift for you to see. And do you think that we have a vertical shifting?
Yes.
Yes. We move it up or down?
Down.
Down because it's -2. You know, usually we put -2 here, but I put it in the front like that. And the negative in front of cotangent here means what? You flip over the x. You flip over the x because that's one of the concepts of transformation we already learned in college algebra. If you have a negative function, you flip it over the x. It's reflect over the x-axis. So let's see. Let's see if we can graph one by one, step by step. Okay, so let's see. So the first step again, our first step is still amplitude. Amplitude is still will give you 1 because amplitude is always positive, so we take absolute of that. Okay, we calculate the period is 2 pi over b in this case. Oh, pi over b. I always say pi over b. So b over here is what?
1.
1, so it's just pi. Well, it's kind of the same as this now. Kind of the same as this now. Okay, we calculate the phase shift. So with x minus pi over 4 equal to 0, so x equal to pi over 4, and you see that it's moving left because it's positive. Okay, and we know that we have to move down. Moving down 2 units. Okay, this is move left. I move right. Move right. Pi over 4 units. Okay. All right. Let's start with our periodic function. Okay, the periodic function now, the period is still pi, which is good. Okay, so let's do like this. Okay, asymptote over here. And we're going to have something like this. So half this will be pi over 2. And we can have a curve that looks like this. Alright, now we're going to start shifting. Okay. So we want to move up, move down 2 units. Or you can do move to the right first. It doesn't matter. It doesn't matter which one you want to go first. Okay, let's move down first. Maybe. Or maybe let's move down. So let's say this is 1 here, -1 here. So you move down, it's -2. So our origin is right here. Okay. So we'll have something like this. Okay. Then we move to the right, pi over 4 units. Okay, so how we know this pi over 4? We know that this is pi, so half of them will be pi over 2. Then another half, right? So over here will be pi over 4. So it's kind of that much. So we're going to move a little bit to the right. So it's just a little bit here, so we move over here. Okay, so origin will be here. And of course the vertical asymptote will be moving also. So it's going to move over here. So this is our vertical asymptote. Okay, and our new vertical asymptote will be here. Okay, I don't have enough other color. I wish I had the red color, but I don't know if we have the red color here or not. Nope. Okay, let's see if we can use this. So right now, we're gonna have something like this. All right. Everyone got it? Now what next? We haven't touched the negative, right? Now we have to flip it. Yeah, okay, so we're gonna flip it. We're going to reflect it about the x-axis, so my final graph will be this. Oh, God, let's see, our final graph will be this. There you go. So this will be our graph. F of x equal to -2, negative cotangent, x minus pi. Okay. Any question? Yes.
I thought period was 2 pi over b.
Oh, the period is cotangent. Cotangent is just pi.
Oh, it's different for cotangent?
Yeah, it's always.
Oh,
It's always. The period over here is also pi. So tangent and cotangent, the period is just pi.
But for sine, cosine.
Say as cosine, cosecant, and secant, the period is 2 pi.
Okay.
I remember I wrote this down last time. Maybe you missed it. Okay. Any other question? Of course, you see that the range over here will be negative infinity to positive infinity. Okay? And again, this, the domain depends. We have a complicated function, the domain will be different. So, you see that when you really graph the transformation, you should have a different color so that I can say yes.
Why is it here, I mean, the parent function not between the y and negative y?
Not between y and negative y. You mean not between? You mean not between negative pi over not between negative pi over 2 and pi over 2? That's what you mean?
Yeah.
Because right now, even between negative pi over 2, what happened?
No,
So-
I mean, it's pi and 0, right?
Yeah, it's 0 and pi. It's different from tangent. Because even between two pi over 2, you can do like this. You can graph the you can do the traditional way. Okay? So, her question is why the graph of the cotangent, the parent is 1, okay, is not between negative pi over 2 and pi over 2, but instead of between.
Not between negative y and y.
Not between negative pi and pi.
Instead of
Be-
0 and y.
Oh, okay. Because the period between negative pi and pi, look at that. The period is not pi anymore. Even between negative pi and pi, you have a pi here.
2 pi.
Yes. You have a pi here and you have another pi here, the period becomes 2 pi. But for tangent and cotangent, the period is just pi. Okay, we can express the whole period between 0 and pi, instead of between. What if I want you to graph, for example, I want you to graph between negative pi and pi, then you have to add another branch. Okay? Yeah, but it's not, the period must be between 0 and pi, so the period is pi. Because if you include, the period is between negative pi and pi, another pi here, another pi, this gives you 2 pi, which is not good. Okay? Any other concern?
So this purple one is final,
Yes, the one I put
and
the arrow.
its asymptote is just shifted to the right
The asymptote, yes, we move it to the right, pi over 4 unit.
compared to parent function.
Compared to the parent, yes. Yes.
If there is amplitude, it wouldn't really make that much of a visual difference, right?
Because right now we're sketching, so the amplitude, it might be a little different, it's more slanted, but when we sketch it doesn't matter.
Yeah.
Yeah, it doesn't matter. For example, amplitude too, it's kind of more slanted. So if the amplitude is 1, you may have something. So this is cotangent, right? So for example, if the amplitude is 1, it's like this, and if it's like more than 1, it's like it's more slanted. You know what I mean? Just when we sketch it, we're not gonna get like 100%, correct. Yeah, we don't need it. As long as we understand what it looks like, we understand the transformation, then it should be okay. And of course, if the amplitude is like a half, then it's become wider, so it's gonna be something like this. You can something like that. And just get wider. Okay. For the sine, cosine, and secant, cosecant, yes, amplitude makes a difference because this is where you start. But we're talking about being slanted or being steeper or less steep. It's not going to change much anyway. So because we do sketching, we not really graph 100% correctly. Okay? I would say I shouldn't say correctly. It should be correct, but we don't want it really perfect. Okay? Any other question? So on the test, I'm not gonna, on the assignment, I just want you to graph sine, cosine. Maybe on the test, I want you to graph cosecant, secant, tangent and cotangent, as long as you understand. I'm not gonna put this on the test in a way. Okay, it's not even a part of the. I don't say it's important or not, because most students who had trigonometry, you really have to take physics, and most of physics concept is based on sine, cosine. You know, for the general physics we talk about, you're not going to touch tangent and cotangent much, you know. So we learn it, we understand it, but on a test, I'm not going to put something like that, you know. It's take a lot of time for you to grab, and you have to use different color to show me your work. Otherwise, it's pretty confusing. Okay. In the textbook, they have another way of graphing, but I don't think that is a good way, because I just feel that the method the textbook show in the book is like a routine. It's like, okay, they ask you to do this and you do that, this. They want you to find a phase shift, you find a phase shift. They want you to do this, that, you do this, and you don't understand why the function is like that. Why the function is it becomes like that. Okay, so I don't want you to use the concept with the textbook, but instead we're using the transformation, that is the concept we really learn in college algebra. Any other question? Cool. All right. Okay. All right. So I don't know if you remember back in the day when you learned college algebra. Actually, the first time you introduced to algebra, you learned some basic concept like a PEMDAS rule. You learn how to combine like term, right? And the purpose of those concepts is to simplify algebraic expression. The reason you want to simplify algebraic expression because you want to solve equation. Okay? In trigonometry course, we also use those concepts to simplify trigonometry expression. Okay? Other than that, we also use some property we already learned, you know, a few weeks ago. So I'm going to just go ahead, write out some property, and we're going to see if we can use those property to simplify trigonometric expression or to verify trigonometric expression or not. Okay? So let's see. So the lecture today, we talk about trigonometry identity or trigonometry property. Okay. Trigonometry. Identity. You can just put it like that. Okay. And there are some of them. The first properties, everybody already knows. This is, just go ahead and rewrite it here. The Pythagorean identity. It is sine square of x plus cosine square of x equal 1. Okay. That formula you're not allowed to forget. You're not allowed to. Come on. This is so important. And number 2, we already learned also this is tangent of x is equal sine over cosine. And cotangent is a cosine over sine. Okay. And we know that cotangent is equal to 1 over tangent and vice versa. So tangent equal to 1 over cotangent also, because we derive this formula from the first two. Okay. That's why we also have this tangent of x times cotangent of x turn out to be 1. And I don't know if you remember on the assignment number 2, right? If you guys had a chance to watch my solution, I think that one of the solutions over there, I mentioned this. The product between tangent and cotangent turned out to be 1. Okay. Number 3, we know that 1 over sine squared, okay, 1 over sine squared equal to 1 of the formula we already learned. Anyone remember? 1 over sine squared give you what? What over sine equal to cosecant? Yes, this is cosecant squared. Okay, it's also equal to 1 plus cotangent squared. Okay, it's one of the basic ones. Number 4. And 1 over cosine squared. What do you think?
Secant.
Secant squared
Plus 1 plus 1 minus.
equal to also 1 plus tangent. So I want you guys to memorize 1, 2, 3, 4, and maybe these two also. The property here, so that when you verify trigonometry expression or simplify trigonometry expression, you can do faster. Okay. This property, this identity, we can use that to calculate a trigonometry function also. But last time, when I show you how to calculate trigonometry function, we use the reference angle and triangle. Okay. So maybe we can go through the one example using this identity here. Let's see. Okay. Let's see. We have an example here now. Right. Okay. Oh, let's see. Let me erase this. So we're gonna, maybe during the process of verifying trigonometry expression or simplifying trigonometry expression, we will have to use the concept we already learned, which is we have to find the least common denominator. Everybody know how to find least common denominator. Maybe we also have to use the distributive property. Every time you see the parentheses, you fold it, you distribute it. Okay. Let's take a look at this. Our example. First one. Okay, so I give you tangent equal to negative 5 over 3. And I want you to find the order function value. And find. And I give you the condition is the quadrant, it is theta. Theta is in quadrant 2. So last time we used the triangle. We draw the triangle, and we find the reference angle, and tangent is sine over cosine, opposite over hypotenuse. Okay, you can do that. But because we learned trigonometry identity today, so let's see if we can apply this formula. Oops. Solution. Let's see. So right now tangent is negative 5 over 3, and we want to find the order of function value, meaning we have to find sine, we have to find cosine, we have to find cosecant, secant, cotangent. Okay. And we know that tangent is the reciprocal of cotangent, or cotangent is the reciprocal of tangent. So from tangent here I can get cotangent easily. So cotangent will be 1 over tangent, be 1 over negative 5 over 3, negative 3. And let's see if it satisfies theta is quadrant 2 or not. So in quadrant 2, cotangent is Negative. Yeah. So it's good. We always have to check if it's satisfied the condition. Alright, so that's cotangent. And now we want to find sine. Or maybe cosine. And you have to check one of the identity here. Which one related to tangent and sine cosine?
Second.
Second work, but when you use second, look at that, if you use second, I have tangent here, but we don't have both of them, sine and cosine. So you cannot find sine or cosine if you don't know, if you have two variables, if you don't know the top and bottom. So maybe we have to use another,
Oh, the first one?
Plus,
the first one.
Because it gives you sine and cosine.
Do you think where we're gonna get sine cosine? Do you give us?
Because it says tangent's -5/3, so isn't that sine?
Oh, we don't want to use, again, we don't want to use the triangle anymore.
No, you don't?
Ah, yes, because right now we learn trigonometry identity. We don't want to use triangle anymore. So what formula are we going to use?
3 and 4.
3 and 4. Of course 3 and 4. It's right over there. Huh? It's right over there. It's right over there. Right here. Right here. So tangent, they give you tangent. Now we can find cosine. Oh, let's see. So we know 1 over cosine square equal to 1 plus tangent square. Okay, so we're gonna plug them in. So 1 over cosine theta. So 1 plus -5/3 square. Yeah, we just give you what? 1 plus 25/3.
9.
Oh, 9. So you 35, 5 LCD. We give you
34.
34/9. Okay, then we make it reciprocal. They give you 9/34. Okay, then you take square root. Then give you cosine equal to plus minus 9/34. Okay, now we go back to the condition. This is in quadrant 2. So which one we're gonna take, positive or negative?
The negative.
We're negative.
Yeah.
Because it's in quadrant 2, cosine negative. You know, you look at this unit circle, okay, cosine is the x-axis, so cosine negative is in quadrant 2 and 3. So my answer will be negative.
Isn't it square root?
You didn't take the square root of the right side.
Oh, yeah. Okay, so I'll give you plus minus 3 over. Well, you can simplify that. Anyone can help me simplify this? 34. Can we? No. So we're not. Because it's 217. Okay, so cosine theta will be negative. So it will be negative 3 over square root 34. That's this cosine. Now we already know cosine. Do you think we can calculate sine?
Yeah.
Yeah. Which formula will you use?
First one.
The first one, right? We'll use the first one. Or maybe we can use this one also if you want to, because we already know cotangent. We already know cotangent. We already calculated cotangent now. We can use this if you want. So, but let's just stick to the Pythagorean identity there. So we can do sine square equal to 1 minus cosine square. So give you 1 minus, you square that, give you this, 9/34. Alright? And go ahead, 5 LCD for me over there. 34 minus 9 will be 26. Okay. Is that 26?
No.
No, 30. 34, you 25 over 34. So from here I can take square root to get sine, again give you plus minus 5 over square root of 34. And which one will you take? Positive or negative?
Positive.
Positive, because this is part 2. cosine, cosine. Now we can get secant, cosecant easily, right? So secant 1 over cosine, and cosine is negative. We already took it, so give you negative square root of 34 over 3. Cosecant 1 over sine, so give you positive 34 square root of 34 over 5. And that's it. So there are two right now. There we have two methods of calculating trigonometry value, trigonometry function. You can use the triangle, or you can use the property, the identity. So on the test, it doesn't matter which one you want to pick. As long as you show me the work, and as long as the work is correct, that's fine. Okay? Unless I really clarify, oh, you have to use this.
For the homework, do you want us to use the identities and not the triangle? Or do you not care on which one we use?
But I don't think that there's a problem related to the, you mean the assignment?
Yeah.
The assignment right now, yeah, of course, we have to use an identity, of course. Okay. So we're gonna go through the example about simplifying expression or verifying expression, and we're gonna use, maybe we use the Laplace rule, or maybe we have to learn how to find LCD between sine and cosine, and of course we're gonna use one of these identity to simplify the expression. Okay. Let's see. Oh, I do have time. So hopefully, as long as we can cover the concept today, you can do number 1 and number 2 of the assignment. Let's see. I have a very interesting one. How about this? I want you to, how about this? Simplify simplify 1 over cosine square minus 1. Now I simplify this.
You could change one over.
So what we're going to change now?
You could turn 1 over cosine squared either to secant squared or 1 plus tangent squared.
Okay, because I can see that 1 over cosine squared is 1 over tangent squared, and 1 plus tangent squared. Right? So if I replace this part here, okay, I replace this part with 1 plus tangent squared. And minus 1, of course, I rewrite it. I see that 1 cancel with negative 1, so my answer is just tangent squared. So this is very simple. Okay? That will be the final answer. You don't have to write the sine square over cosine square because that's good enough. Okay? So for a simplification problem or verifying problem, you have to know, you have to make your own decision when you have to stop. Especially for simplifying expression, you know. Some students don't know when to stop. We talk about this already. Because, back in the day when you learn algebra expression, you want to combine like term, you distribute days and distribute that, and you don't know when you stop. And you think like there's something else to do, and the students just keep asking me like, okay, can we stop right here? That question, that decision, you have to make your own. Okay? And how we're gonna make it? You're gonna do a lot of problem. As long as you do a lot of problem, you can realize yourself when you have to stop. Okay? How about this? How about this one? This is a little bit more complicated. I don't think it's really that bad. Example 2. theta minus 1. And at the bottom, I have cosecant square theta minus 1. Alright, I want to simplify this. What do you think? What will you do?
Secant squared minus 1 would equal tangent squared.
Secant squared minus 1 give you tangent squared. Oh, that's good, because you can see that she subtract both sides by 1. You see that secant squared minus 1 give you tangent squared. So I can write this. Secant squared minus 1 is tangent squared. And we do the same thing for cosecant squared minus 1. Cosecant squared, you guys subtract both sides by 1. It's cosecant squared minus 1 give you cotangent squared. And tangent square over cotangent square, you can use this formula, this relation between cotangent and tangent. You see the cotangent square, I can change it to 1 over tangent square. And tangent square over 1 over tangent square give you what?
Tangent to the power of 4.
Tangent to the power of 4. So it will be tangent to the 4. Okay. Because keep changing it. Tangent square times tangent square tangent to the 4. It's like x times x squared times x squared is x to the 4. Okay. And don't write like this, okay? This is different from this. Some students write like this. So this is the third square, not the tangent square. So if you want to write like this, you have to write the parentheses. This is the same as this, but it's not the same as this. Okay, so be careful. The parentheses change things. Okay. So there's a many different approach of simplifying the expression. I can change secant square equal to what? Secant square equal to 1 over cosine square also if I want to. And I can change cosecant square equal to 1 over sine square if I want to. Okay, then afterward I'm going to use least common denominator. Okay, and then simplify the top and the bottom. It turned out to be the same also. Let's try that method, okay? Let's try that method. So it doesn't matter which one you want to use. You know, mathematics, we don't learn it by routine. You use some logic here. So let me use that strategy. Let's see, we reach the final answer now, okay? So secant square theta minus 1, or cosecant square theta minus 1. So I change secant is 1 over cosine square theta minus 1. This is 1 over sine square theta minus 1. Okay. And I find LCD at the top. Okay. You see that one method will be taking longer than the other. So I find one LCD on the top. This is 1 over R1. So I find LCD and I have 1 over cosine square theta over cosine square theta over 1 minus sine square theta over sine square theta. FILC. And 1 minus cosine square give you what? Look at that. 1 minus cosine square theta give you sine square. Because if you go ahead and subtract both sides by cosine square, give you sine square. So give you sine square theta over cosine square theta. And 1 minus sine square theta give you cosine square. So you see that how Pythagorean identities form. And sine over cosine give you? See, you go back to, and this is give you cotangent. And now it's turned out to be the same as here. I'm not going to keep going because you should be okay. So you can start with different approach. You can use different identity. As long as they give you the final answer, that will be fine. Okay. Okay. Actually, there's another approach, but I don't think we need to go through that. As long as you really know how to do one. As long as you know one approach, it will be alright. Okay. Okay. So that is the question where they ask you to simplify expression. So you see that on the assignment here. Yeah, in the assignment, the first question here, I give you A and B, right? And I want you to simplify that, so you have to manipulate some way somehow, so that it becomes simpler. Okay, and again, you need to make your own decision when you have to start. Okay, which one is the simplest form of these two questions here? Okay. Let's say we can learn how to verify expression. Verify will be a little bit harder, but it's not, again, it's not really that bad. Okay? Let's see. I have some very interesting problem here.
So like tangent equals sine over cosine, so tangent squared would equal sine
Square
squared
over cosine
cosine
squared.
Okay,
Yeah, so we square this, and we square each of the term.
Okay.
Term there. Or tangent to the 4 will be sine to the 4 over cosine to the 4.
Okay.
Okay. So you see that all the property we learn in algebra, we can it can be applied here. Okay. Let's see. So I don't want to erase it because you guys have to memorize this. Just right now, just leave it over there. Okay. Example number 3. I want you to verify expression. And I have something like this: tangent of x, of course, times sine of x, plus cosine of x equals secant of x. I don't know, you guys. Yeah, because you guys never been introduced trigonometry in high school. I remember when I was 15, 16, 15. That's the first time I learned trigonometry, and I really like the question verifying. It's like proven. So in the lower level, we call verify, but in the higher level, it's considered as proven. It's a part of proven.
So it's
Okay.
tangent times.
Tangent times sine.
Okay.
Plus cosine x equals secant. Because this kind of question is train your brain. It train your mind to think logically and critically. You know, this is, believe me, this is kind of simple question. When you have like crazy question, it's hard. It's really hard. Okay. But again, I'm not going to give you a really hard part. But believe me, when you know how to do this, you really love it, guys. You're just like, oh, I got it. Believe me, that's the good thing about math, because you find it and you find out things how to, and you get the final answer. You feel like it's wonderful, man. You feel like you just accomplished something, man. That's what it is. All right. So when the question asks you to verify trigonometric expression, there are 3 different approaches. So let's talk about the general approach. Just help you to do this. Okay. So the first approach, okay, is you can go. What I mean, you can go from left to right. From left to right. It means when I say go from left to right, it means that you can show whatever you have on the left hand side, which is this part right here is the left hand side, turn out to be the right hand side. Or you can go from right to left. It means that you start from the right and you're going to manipulate, you're going to convert some way, somehow, you're going to use trigonometry and identity, you're going to use all the property where you learn in algebra. You bring it back to this form. Okay, that's the second approach. Or the final approach, which is we can go from both sides. It means that we can start from the left hand side. We manipulate some way somehow. Then we start the right hand side. We manipulate some way somehow. And it turns out to be something true all the time. For example, you have an algebraic expression, okay, on the left and the right. You manipulate some way somehow, and it turns out to be like 1 = 1. And 1 = 1 is true. It's always true. It's fact. Then you show that, you just verify, oh, this expression is true all the time. Because 1 = 1 at the bottom, show me that on the top, the original expression is true. So if you can show at the end, both sides equal to each other, and it's true, it's fact. It means that this original expression is true. That's what it means. Okay? But with my experience, it doesn't matter which one you go, yes. But I always go from the side that has more function. So which side has more function?
Left.
Good, that one. Because it's very hard to start from secant. You have only one function and you don't know where to start. Maybe secant is, you can start from here to here, and some way somehow to go back to that. It's harder. So I go from the left to the right in this example because if you go from the side that has more function with my experience, and it's always work. Okay, I barely use number 3 approach. Sometimes depends on the question. Okay, sometimes you try the first approach, doesn't work. You screw up, or maybe you cannot go anywhere. You try the second approach, you still screw up, it doesn't go anywhere. Then you have to do the third one. Okay. Let's see if we can do from left to right. Alright. Because we go from left to right, so let's start with the left. Go ahead, rewrite the left. Equal. This is the reality, guys. A lot of students don't like verifying. A lot of students don't like, but still a lot of students, they really like this. When you really go into mathematics, this is good, man. This is crazy. This just train your brain. You train your brain, not just for math. You train your brain a lot of things. You train you how to think ahead. All right. So what we're gonna do now? We want to get to secant. And secant, you think like the secant is what? 1 over what?
1 over
Sine. So it means that we manipulate some way, somehow, so that at the end we have 1 over sine. That is equal to the
cosine.
other 1 over cosine. Yeah. Okay, then it gives you secant. Yeah. We manipulate some way, somehow, so that at the end we have 1 over cosine. It gives you secant. Let's see. Yes.
So I think I see how you do it. Can you change tangent into sine over cosine?
Yes, that
And you
was one of
multiply
the multiply.
the sine over, so you get sine squared over cosine. Then you get a common denominator.
The common denominator.
That is cosine. So you multiply cosine over cosine.
That's
so
a
then
very good strategy there. Because, look at that, I changed this, tangent is sine. So this equal, okay, sine over cosine. And I multiply sine over here, I rewrite it. So I rewrite this part too. Okay, and sine times sine give you what?
Sine
It
squared.
give you sine squared. So I have sine squared theta, x over the cosine x plus cosine x. And according to him, he said that what do we need to do next?
A common denominator.
A common denominator. A common denominator because we have two fractions here. So he kind of thinking ahead. Okay, maybe I do like this. I can get something. I can simplify stuff. You know? So I find this denominator and I see that on the top I have sine square here plus cosine square here over cosine x here.
So the top would equal to 1 then from the first property.
And right now we have 1 over cosine give you
Secant.
done. So you have to think ahead, guys. You have to think ahead. And I look at this and do you think that we may have another approach? Instead of changing sine over cosine, can we do anything else? Or maybe that's the unique way of converting to secant. Can we have another way?
Yeah.
What do you think?
I changed sine to tangent multiplying by cosine.
Okay, you should change sine to tangent to multiply by cosine because someone used this. Tangent to over cosine. So she do like this. She keep this and she used this formula here. Sine is tangent times cosine. So it will be tangent times cosine. And she keep this. I believe so. Then what next? Then she multiply that. Then give you tangent square x times cosine plus another cosine here. Let's see it work. Then what?
Cosine x as common.
This is GCF.
Yeah.
So you take them out cosine x, you take them out, so tangent square x plus 1. And tangent square x plus 1 is what? Secant square. And secant square is
1 over cosine squared.
ah. And you simplify this, it gives 1 over cosecant. And this gives 1 over cosine will equal secant x. So there's different approach of doing this kind of question. Doesn't matter. As long as you show me the logic. As long as you show me the step. Don't just jump from here. Some way, somehow you get to here and here. I was like, what? Oh, you jump from here and you skip 3 steps, and from here to boom. Ugh. Well, maybe you're genius. Well, but at least you have to show me you're genius. Okay. So actually, some students, yeah, they can think ahead. It's like you playing chess. You know, you think ahead like many steps. Alright, I think that's all for today. Next time we're gonna go a few more examples. Okay, related to simplifying express and verifying expression. But today that's all. If you guys have any questions, let me know. Any concern, please let me know. Okay, don't fall behind. Everything's good. Look good so far. Okay, you guys don't have to worry about the test. We'll have it next week. And even you screw up with your test, that's fine. Just the first test. Don't panic. Don't panic. Go ahead, turn it into assignments. Okay, go ahead, grab the assignment if you don't have it yet. So go ahead, grab the assignment. Assignment number 4 is due. We'll take this again. Yes.
It was literally just take it. I'm confused. Why would you even?
was going like this.